Welcome back to another episode of This Is Your Nervous System. Okay, so after this one, you will have a quiz over yesterday and today. So this is for Wednesday. Okay, just a review real quick of neurons. These are dendrites. These are what will get the chemical signals, the neurotransmitters from other neurons. So this is a previous neuron. Then what will happen is if the neuron is excited, you will get what's called an action potential that will travel down the cell body, the axon. Remember, the myelin sheath is what speeds it up, and the action potential will travel all the way to the end to these things called the axon terminal. And then in these axon terminals are going to be neurotransmitters, which are chemicals, which will then be released and then either excite or inhibit the next neuron. So what we're going to do is we are going to talk now about synapses. To me, when I teach anatomy, this is one of the most interesting topics because everything that goes on in your brain is related to synapses and how neurons communicate with each other. Okay, so just so you see this is the end of a neuron right here. Okay, this is called the presynaptic neuron. And then this is the postsynaptic neuron, which is the dendrite of the next neuron. Okay, it's the dendrite of the next neuron. So this is the synapse. It is a physical gap between this neuron and this neuron. So electricity is what travels down here and travels and gets the signal to go from one end of the neuron to the other. But to get the signal to travel, you have to have a chemical which will go across this gap. Okay, so let's start with this is the presynaptic neuron. This is representing the what's called an action potential that travels down this neuron. At the end of the neuron is these globs, whatever, of what are called neurotransmitters. Okay, and they sit here at the end of this neuron. So the action potential on the presynaptic neuron causes calcium channels to open and the calcium to enter the neuron. So this action potential opens and calcium comes rushing in. Okay. What that calcium is going to cause is these vesicles of neurotransmitters then to come to the cell membrane, okay, to come to the cell membrane and be released into the synapse, be released into this gap. So we have these chemicals that are being released into the synapse. What they will do is they will diffuse, they will move across the synapse to the postsynaptic neuron, which is here. And on this postsynaptic neuron, there are receptors. Okay, there are receptors. Then what will happen is if these neurotransmitters fit into these receptors, if enough of them fit into these receptors, what it will do, if it's excitatory, it will excite this neuron, and then an action potential, that electricity, will be signaled and then travel down this neuron. So some neurotransmitters are excitatory, which means when they bind, if enough of them bind to these receptors, then it will excite the next neuron, and then that neuron will generate electricity. That is called an excitatory postsynaptic potential, if an excitatory neurotransmitter binds to here. If we don't want this neuron to be excited, we want to inhibit it, then what would happen is you would have the release of a different neurotransmitter, which would bind to a different receptor. Okay, so on this model, they only show you one kind of receptor. But when it comes down to it, there are really at least 2 or 3 different types of receptors, shaped receptors, and 2 or 3 different neurotransmitters that can be released. If the neurotransmitter is released is different and binds to a different receptor, then what that can do is that can stop this neuron from firing. And that is called an inhibitory postsynaptic potential, or what I like to abbreviate IPS-PIPS. Okay, so you have EPS-PIPS, which excite it, and excitatory neurotransmitters, and you have an inhibitory neurotransmitters that inhibit this one from firing. Now, you may be asking, why would you want a neuron not to fire? Let me give you an example. Your body and your brain and your neurons are constantly being regulated in your brain and throughout your body. So I'm going to give you an example of when inhibitory postsynaptic potentials are not functioning. So if you've ever known anyone who has epilepsy, or you've seen or experienced a seizure, what starts to happen in a seizure is neurons are firing uncontrollably. You're having a bunch of excitatory postsynaptic potentials, and the inhibitory postsynaptic potentials are not working. So neurons are firing uncontrollably. And so that leads to chaos. So your brain is a constant up and down regulation of neurons firing when you need them to be, and then neurons not firing or being inhibited when you don't want them to be. Okay, so you have all these different neurotransmitters that are regulating either turning neurons on or turning them off as they should be. Now, once these bind to these receptors, then what has to happen is they can't stay bound there forever. So number 4 here is representing either the breakdown of these neurotransmitters. So they will bind and either excite or inhibit, and then they'll be broken down. If we want to continue to excite it, then we will continue to release neurotransmitter to excite the neuron. Or if our goal is to continue to inhibit the neuron, then we will keep releasing neurotransmitters that inhibit it. But either way, we have to break down the ones that bind, and then a lot of times what your body will do is recycle them. It's called reuptake, the reuptake of neurotransmitters. And that's going to be important because there's some medications that deal with depression that will deal with controlling the reuptake of the neurotransmitters. So it's going to be released, it's going to bind. Depending on the neurotransmitter, it's either going to excite or inhibit this neuron. Okay. And then it's going to be broken down and many times recycled, and then it can be put back together again and then reused. Okay. So that is the basics of a synapse. Okay. Okay, so that's the basis of a synapse. This is just showing you representing each of these parts, which again, you will get a picture of this. Okay, so it shows you the calcium channels, shows you the calcium going in when the action potential comes down. Then it shows you the neurotransmitter represented in purple in the synaptic vesicles that carry it. Then it shows you here the receptors for it. Okay, shows you the postsynaptic neuron, and then it shows you the transporters. It uses that word. The transporters are just what's going to help with the recycling of that neurotransmitter when it is broken down. Okay, and this just represents again what I've already talked about, that some neurotransmitters will excite this next neuron. Okay, so this neurotransmitter may excite, that's an EPSPIPS, an EPSP, or it may inhibit this one. It may stop it from firing. And again, remember, that is just as important as we're regulating the brain, okay, and the nervous system of the body. Okay, I'm going to give you some examples of neurotransmitters. This may cover most of them that you may research, depending on what medication or what disorder or what drug you're going to research. If you come across other ones and you're not sure about them as you do research, I am more than happy to help you with them. So let me give you some examples here, and this is not all encompassing. Neurotransmitters and brain chemistry, I think, is so interesting. And a lot of these neurotransmitters do more than one thing, depending on where they are in the brain, okay, where they are in the brain. So one I'm going to talk about is dopamine. This is a pleasure or a feel-good neurotransmitter. And you actually have a lot of naturally occurring neurotransmitters that make you feel good. And dopamine is one of those. It's a pleasure, okay? It's a pleasure neurotransmitter. So you've probably heard me say that we are all addicted to our phones, and we are, including myself. And so what happens is when you look at your phone, your brain secretes dopamine, and it's in what's called the pleasure pathway of your brain. And it makes you feel good when you do that. Okay. It's like when you're eating your favorite food, you secrete dopamine in what's called the pleasure pathway, and it makes you feel good. Cannabis does that. Okay. Marijuana also does that. A lot of drugs do that. They increase the dopamine. Now, when you're talking drugs like heroin and meth and those kind of drugs, those kind of highs that you get, you get a lot more of a neurotransmitter. So when you look at your phone, you get what you call a dopamine hit. When you eat a piece of candy that you really like, you get a dopamine hit. It makes you feel good. When you're talking the other types of drugs, then the amount of dopamine that's secreted, or the amount of dopamine-like neurotransmitters that's secreted, is much, much higher. Endorphins are another, okay? And let me go back to this, the dopamine, real quick. So when you don't have your phone in front of you, you know that feeling. And if you don't know it, then pay attention to it. We all have it, where you just want to look at your phone. So when I take your phone or you put it in the caddy, you want to look at it. There's that urge. That's because your brain likes to feel good and because the phone makes you feel good. Now, that doesn't mean it's a real positive addiction. We all have it to some extent, those of us that use our phones, but you're going through almost like a little withdrawal when you feel that need. And when you see your phone and something pops up, then you get that little dopamine high. Okay, you get that little dopamine high. You know, on most social media things, that scrolling, that you can keep scrolling and keep scrolling and keep scrolling, that is very addicting. That causes little dopamine shots in your brain that want to make you keep doing it and then not put it down. Okay. So dopamine's good. It's not a bad thing. There are things that you can do that make you feel good that are healthier than using your phone. But that is what we're talking about when we talk about addiction. Endorphins are another feel good hormone. If you ever heard someone who gets runner's high, if you get people that exercise a lot, that feeling they get when they exercise, that's caused by endorphins. They give you a high, a natural high. They also can decrease the pain sensation. You see athletes sometimes that, they've broken something or torn something and they still are producing well, and they still are doing things very amazingly so on the field, and they can keep doing that. It's because endorphins a lot of times will be a kind of a painkiller. GABA stands for a big long word, gamma aminotropic butyric, blah, blah, blah. I can't remember exactly, but GABA is the abbreviation. It's a major inhibitory neurotransmitter. So it slows things down in your brain when it should be. So we talked about inhibiting. So this is a major inhibitory neurotransmitter. But one of the things that alcohol does when you're drinking alcohol is it increases GABA. It increases to a point that it decreases your reflexes. It's over inhibiting your brain. Okay, it's over inhibiting your brain, so you don't react as well. It causes you to do things you normally wouldn't do or that you would inhibit. It causes you a lot of times to say things that you shouldn't say, because what happens is it's inhibiting the part of your brain that tells you I shouldn't be saying those things. And so that part of your brain's not working as well. And so the part of your brain that wants to say things that probably aren't appropriate is increased when you're under the influence of alcohol. Okay. So again, a good neurotransmitter, they all play a role, but drugs will change them. Serotonin. Serotonin is a mood booster. It makes you feel good. It's probably not as strong as dopamine. It's kind of a calming, feel good kind of neurotransmitter. But in the cases of depression, people with physiological depression can have lower levels of serotonin. And there are drugs called SSRIs, which will actually increase the serotonin. So SSRIs will be taken by people that have depression, and it can increase your serotonin levels. And actually, let me show you how it does that. So SSRIs, which are a common type of medication, what they will do is they will inhibit the reuptake of serotonin. So what that does is you're not recycling it as much. So what it will do, it will increase the serotonin in a person's synapses, which will decrease the physiological effect of the depression. Okay. Some people, and some of you may choose to do this as your topic, different, not opinions of depression, but causes of depression. There have a genetic component that people are born sometimes with a lower level of serotonin. Other times, going through life's hardships and some issues can actually cause serotonin levels to get lower. Many times in depression, it can be a combination of different things. So that can determine what type of medication and how much medication they may give a person. Another neurotransmitter is acetylcholine. Acetylcholine, every time one of your muscles contracts, it's because a motor neuron has secreted acetylcholine, which stimulates the muscle fiber to contract. It's also involved in short-term memory. So when you're memorizing a number or learning a new name, acetylcholine is involved there. I will tell you, in the case of Alzheimer's, one of the things they see in a certain part of their brain called the hippocampus is the acetylcholine levels go down, so they're not able to form short-term memories. The last one I'm going to talk about is glutamate. Glutamate is involved in learning. So as you're learning something new, whether it's a fact or a physical thing to do, your glutamate is being secreted. And one of the negatives of glutamate is that we found in a stroke. And what happens in a stroke is blood flow to a certain area of the brain is decreased. Neurons will die very quickly if they don't have blood flow because they need oxygen. And what will happen is, as neurons start to die, they actually will send out what's called a glutamate cascade. They'll send out large amounts of glutamate, which for some reason causes other neurons to start to die. So a lot of times the effect of a stroke may take a few days to realize what parts of the brain have been affected, because as neurons die, it's kind of like, well, if I'm going to die, then I'm going to tell you all to die. And so it sends out this signal, which then causes death of other neurons around it. Okay, so that is just a basic overview of some of the basic neurotransmitters and what they do. As you go through your project, you will find probably more explanation, more examples of different types of neurotransmitters. The last thing I want to go over, and I know this is a longer video, is what can happen, the basics of what can happen with addictions. Whether it is caffeine, whether it is nicotine, whether it is something like meth or heroin, the basics of what happens to synapses is pretty similar. So, with taking certain drugs, what will happen is the drug will either increase the secretion of natural neurotransmitters, or the drug will mimic the neurotransmitters. And what the synapse will see is it will see a large amount of a neurotransmitter, whether that's from the drug or from the effect of the drug causing neurons to secrete more. But what happens is the synapse sees an abnormally large amount of certain types of neurotransmitters. And the body's going to modify that. When it sees a lot of something or a little of something, it's going to try to adapt. Okay, it's going to try to adapt. So what the body can do in response to drugs is it can actually increase or decrease the natural amount of neurotransmitter that the brain makes, or it can increase or decrease the amount of receptors on the postsynaptic neuron. So if it sees a bunch of neurotransmitter, much more than it should, then what it might do is it might stop making as much neurotransmitter, or it may decrease the number of receptors. But then what happens is, when that person's not taking the drug, it now screws up their synapse. So I'm going to give you a quick example. You take a drug and it increases the dopamine levels by a ton in your synapse. Well, your body's like, whoa, that is way too much. So what it does when it sees that is it will decrease the amount of dopamine that it's naturally making, and it will actually decrease the number of receptors for dopamine. Because it's like, well, if we've got all this, we've got so much of it, we don't need to make as much, and we don't need as many receptors. The problem with that is, now when you stop taking the drug, you now don't have as much feel-good neurotransmitter, and you don't have the receptors for it. So you feel really crappy. And that is the withdrawal effect, and that is the craving for a drug, because you're not making as much natural neurotransmitter. You just don't feel good until you try to take it again, until you take it again. Okay? And so when you don't take it again, because you shouldn't be taking it, then what happens is your body has to go through that withdrawal. Now, not to this extent, but the same thing happens with smoking and with coffee and caffeine. Okay, those are addictions. They're not as strong as, like, say, meth or heroin. But with meth and heroin, they are the two most addictive drugs, physiologically addictive drugs a person can take. And the reason for that is they have the most dramatic and quick effect on synapses than any other drug. So what happens is people that have taken them will tell you that the first time they've taken them, they've had the best high. It's the highest high they've ever felt. But what happens is almost immediately their synapses start to change. And so they take the drug, they have the high, then they start to crave it and they take it more, but they don't get the same response. And they just keep taking it and taking it, trying to feel good. Okay. But it's hard for them to feel good because their synapses have changed and their brain has been modified. And that's why withdrawal and craving is so difficult. Okay, so that's some basics on addictions. Again, I know this is a longer video, but I wanted to make sure I get through this topic. So make sure if you need to watch it again, take some notes. I am going to give you a quiz on this. Obviously, you can use your notes because I can't stop you. So make sure that your notes are good and that you're ready to take the quiz.